Yeah, welcome to 13 Universal. Okay, this is biology section with schedule. So you're welcome. So we're going to be discussing some questions on A-level CI biology, and we're going to be looking at cell structure series 1. So please stay connected as we go on this journey. Okay. So let's look at the first question. The first question says, you can see there, it says a light microscope is used to observe two membranes that are 200 meters apart. Sorry, 200 nanometers apart. Then the question says, how far apart are the membranes when the objective lens is changed from low power times 40 to high power times 400? How far apart would it be? Okay, now there's something. Now A says 2 micrometer, B says 20 micrometer, C says 200 nanometers. All right, and D says 2000 nanometers. Now if you look at that, you see of course that the actual size is 200 nanometer. The actual size does not change. Okay, even as you increase magnification, the actual size does not change. If you remember the formula that says, if you look at this, the relationship, that image, okay, image is equal to look at that. So the image, right, image is equal to magnification, that's actual size, times magnification. Is that okay? So when you increase magnification, which is the independent variable, okay, the image size increases. This is dependent, okay, but the actual size remains constant. So if they are 200 nanometer apart, that means it remains 200 nanometer apart, okay. So it will never change. No matter how you increase magnification, it does not affect the actual size. So the answer is what? Guess what? The answer is C, 200 nanometer. Is that okay? All right, so let's go to the next question. Question 2. You can see that. So the question says the electron micrograph is of a chloroplast. So this is a chloroplast. You can see the length of the chloroplast among the lines shown is 80 millimeters. 80 millimeters. The actual length of the chloroplast is 10 micrometers. Okay, so the question now says, what is the magnification of the chloroplast? Now you see, these are the answers. I want you to pause this video and try to solve the questions. Okay, pause it. Okay, meanwhile let's try to solve this question, right? Let's try to solve the question, and of course we're going to have something like this. See, don't forget that we're looking for magnification. So magnification, right, is equal to, like you always know, image size, all right, over actual size, A. Okay, this formula is very important. Now in biology we try to work with micrometers. So this is in millimeters. So if you're converting from millimeters to micrometer, you just multiply by 1000. Is that okay? So if you multiply by 1000, that gives you your answer in micrometers. So 80 millimeters times 1000 will give you 80,000, right? 80,000 micrometers. 80,000, 800. So all over actual size is 10. So this is 80, okay? 80 all over 10. 10 micrometers. So when you cancel this, cancel that, we have 8,000. So 8,000 is the same thing in standard figure. It's 8 times 10 raised to power what? What's the answer? Okay, guess this right. 8,000 is 10 times 10 raised to power 8 times 10 raised to power 3. So the answer is B. All right, thank you very much. Please remember that this is from 13 Universal, learning beyond borders. Okay, so drop your questions on our channels. Please like, share, and comment. Thank you. So let's go to the next question quickly. So the diagram shows a chloroplast from electromicrography. Okay, so that's it here. So we have the length of the chloroplast from X to Y is 5,000 nanometer. What is the magnification? So I want you to pause and try this question. Pause and try it. Okay, pause and try this question. All right, so let's see how it goes. So we have of course you can see, like we said, we're looking for magnification. Don't forget that magnification is always m is equal to image, okay, size, which is I over actual. Okay, actual is A. So what you do here is to get the image size. This is the image. You put your ruler and measure from here to here. Now this is about five it's about 5 centimeters. Okay, if this is about 5 centimeters, and then to convert centimeters to is 5 cm, to convert 5 cm to micrometer, multiply by 10,000, and that gives you 50,000. Yes, so this is 50,000, because to move from micrometers, centimeters to micrometer, you multiply by 1,000. So this gives us 50. You multiply by 10,000. Okay, you're moving from centimeter to micrometer, you multiply by 10,000. Is that okay? But if you're moving from millimeter to micrometer, you multiply by 1,000. So this is 50,000. Okay, so meanwhile we have to convert this one back to micrometer. This is already in micrometer, so everything should be in micrometer. Is that okay? So everything should be in micrometer. So if you convert this, divide, if you're moving from nanometer back to micrometers, so you're dividing this 5,000 by 1,000. So you divide by 1,000 is going to give you 5. Okay, 5 micrometers. Alright, so that is our actual size. All right, so let's get back to the game. So I wanted to pause and solve it. So now we have image size to be 50,000, which is 5, right? 50,000. This is 50,000. Sorry for the slow dragging of the marker. Okay, so but okay. So 5 divided 50,000 gives you 10,000, right? Now let me say this disclaimer to this question is that sometimes you may not get exactly the answer, right? Because the font they use for this in the real paper, exam paper, is not the same font here, right? So I just estimated, however, it's still the answer here. Okay, so in the real exam paper, you have to measure this from here to get your image size. Measure this. Even if you get it in centimeters, you convert it to micrometers, which is basic unit for calculations. And then when you convert it, then of course that is how we got 50,000 here. We assume this is 5 cm, so times 10,000 cm to micrometer and multiply 10,000, that gives us this. Then divide by, of course you're going to make sure that they're all in the same unit. This is micrometer too, so we're moving from nanometer to micrometer. Okay, so that's how we get the answer. If you have questions, let us know. Okay, thank you. Let's move to the next question quickly. Now this question is very interesting. The question says eyepiece graticles and stage micrometers are used to measure cells. All right, they used to measure cells. Which is the correct reason why eyepiece graticle is calibrated? All right, let's run through it. But as well, you can pause and look at it. Okay, there's an eyepiece graticle can be used to make measurements. Okay, this is correct. So use it to make measurement, but the measurement will be in eyepiece graticle units, EPU. Okay, now this sounds correct. Let's see why these other ones are wrong. B says an eyepiece graticle is magnified by the objective lens. No, it is not magnified by the objective lens. It is embedded on the eyepiece lens. Okay, so what the only things that are magnified by the objective lens are the things that are on the stage of microscope. All right, so whatever that is magnified by the objective lens is the one that is viewed directly by the objective lens. Whatever is on the eyepiece lens is not magnified by the objective lens. All right, so this is wrong. See, it says an eyepiece magnifies the specimen. It does not magnify. It's not a lens. It's just a measuring scale. It's not a lens. So this is an eyepiece graphical makes comparison. It doesn't make comparison. So the answer is A. Okay, let's go to number 5 quickly. Which structure is measured in the units shown using light microscope? Good. This is very important. Which structure is measured in the units shown using a light microscope? Okay. Now look at this. Light microscope cannot substantiate, can't resolve cell surface membrane, even though this is correct, but it can't see it clearly. It cannot see cell wall clearly. It cannot see ribosomes clearly, because it has low resolution. It can only see chloroplast, and because chloroplast is a bigger organelle, we measure it using micrometers. Okay, now the unit for this is not wrong. All right, the unit of this, but you cannot quite measure using light microscope. You can measure cell surface membrane, cell wall using it, because they are not well resolved. Neither can you use light microscope to see ribosome, but it can be used to see chloroplast, and that's the unit. Okay, so that is why the answer is C. All right, so let's go to the next question. This is very important, very interesting. It says the diagram shows a state micrometer viewed with an eyepiece graticle using a magnification of times 400. Now, using the same magnification, a chloroplast is measured and found to be 4-piece graticle divisions long. How long is the chloroplast? Okay, so guys, you can try this question, right? If not, you can just come here. So let's find the calibration. Can you see calibration? These big divisions are for stage micrometer. So from here to here is the division between one stage micrometer. Okay, so this is the point of interposition. That is a point of interference, or you can call it the point of intersection, where this intersects with eyepiece graticle. These eyepiece graticle divisions, they are the tiny ones. All right, so you can see that the division here superimposed with, so that's point of superimposition. Superimposes with this, while this superposes with this. We have another one here, but we already have this. So that means that from here to here is from 50 to 90. So if you check the eyepiece graticle between them, that is like 40. So 40 eyepiece graticle unit gives us 0.1 millimeters. Okay, all right, so that 40 gives us 0.1. so you see 40 eyepiece graticle, okay, EP, right? 40 EP gives us 0.1 millimeter. If you convert it to micrometer, you multiply by 1000, that will give us 100. Okay, 100 micrometers. Okay, so that's 100 micrometers. 100 micrometers. So this is 440. This is 40, because from here 50 to 90 is 40. Eyepiece graticle gives us, okay, it gives us 100 micrometers. That's 100 micrometers in length. Okay, so but based on the measurement, micrometers. So from the question, we're looking for 40 eyepiece. 4 eyepiece graticle divisions. 40 gives us 100. So 4 will give us what? For eyepiece graticle EP, okay, eyepiece graticle divisions will give us what? You just cross and multiply. That will be 4 times 100. Okay, 4 times 100. So all over 40. Okay, all right. So that will give us, of course, this cancels that. That will give us 10. Okay, this is 10. And which option do you think is the answer? Okay, the answer is A. Please, you can pause this video, and of course you can go back and solve the questions. Watch this video again, but we want to encourage you, please like, subscribe, and share this video. we're going to be bringing to you the next series, which is series 2 on cell structure. We'll continue solving questions on microscopy and then on cell structure. Thank you for visiting our page. Like we said, kindly leave your questions at the comment section. All right, thank you very much. Bye. Thank you so much. Thank you.